Our next speaker is said to be an enthusiastic and creative individual who brings a strong engineering instinct, lateral thinking, and analytical approach to his projects to deliver solutions that are complex, technically demanding engineering problems by applying leading-edge analysis such as nonlinear FE. He's developed his engineering management skills on a wide range of challenging and architecturally driven products. Please welcome Peter Lenk.
I was thinking John is speaking about someone else, but I think it's probably me. But anyway, good. Good afternoon, or late afternoon. So I'm Peter Lenk, I'm from Arup, London. And today I will be speaking about some of the projects which we are working right now on. And I was thinking hard about the motto of today's conference, about way to grow. And I think when retrospectively you will listen to my presentation, you will find out why I choose the project and why I choose to speak about where I'm speaking now. So lately, at least in the UK, we had a lot of discussion about the growth. Some of the prime minister went down, some of the new came up. The growth is still on the topic. I guess it is the only thing which is understood in our economy. We need to grow, otherwise if we don't grow, then the financial model and the business model is not working. So I think this is probably, at the moment, the best what we can do, grow. However, it is predicted that 80% of the buildings which will be occupied in 2050 already exist. And this is according to UK Green Engineering Council. So this is a challenge, how we are as an industry, as engineers and contractors are going to grow if everything is built. Still 20% to build, which is quite enough for us to sustain ourselves, but are we going to grow? However, we built already a couple of the things, and we know that some of those things are valuable, and we would love to restore them. Good for glass is that we build a lot of buildings from a glass as well. And this is one of the first structural use of glass, I would probably say. If someone disagree, tell me. But Norman Foster's built this glass facade, which is sustained by cantilever glass fins. So what I'm going to speak today is a bit about terminology, influence factors, what it is to design with existing glass buildings, and then I will show a couple of the project examples, which I can say will be quite limited because some of them are quite difficult in the moment, and they are in the construction anyway. So engineering the past to build sustainable future is the motto. And I will start with a lot of R's. And there is a rehabilitation, renovation, refurbishment, remediation, renewal, and restoration. And all of those things means different approach to the building and to the construction. And I think me not being English speaker, I can very easily mix up some of those terms, but that will mean a lot bigger difference to what is actually going to be built. And I think we have in UK at least the Planning, Listed Buildings and Conservation Areas Act from 1990. And a lot of those buildings from early 1970s and 80s, 90s, even 2000s are already listed. They are already protected by law. And we have very limited opportunities to change something on them. And very difficult discussions to have with a lot of people. So what are the influence factors for us as decision makers when we approach some of those projects? So obviously we will need to speak about architectural and sometimes even engineering quality of the project. We need to understand what the clients want, what are the sustainability factors and focus, and then we will come up with some design options for you. So as I said, architecturally, glass played important role in architecture. And we wrote a couple of the books about it, and we promote it for past 30, 40 years, and it's still vital and important material for architects to play with. However, we are also challenged by sustainability, carbon, and global warming. And we need to do something about it. Otherwise, we may have no future. So there is this idea of stranded asset, which is usually can be a couple of the things. It's a commercial problem where the asset is failing to attract tenants or revenue. Maybe a statutory problem where the asset is not meeting current or near future regulations. Or there is a disruptive event, failures, accidents, fire, which is changing the value of the asset. And obviously clients and people which are in the retail, in the business, they already know that, and they have a threshold value at which they really need to do something with the building, because if they don't do anything, if they don't do the retrofit, the asset will start dropping in the value, and then it is obsolete. So there is a life cycle of the project, and we can speak about the new and shining, but as I said, a lot of them are already old and nearing the end of their life. So how can we get the building which is nearing end of the life to the beginning of the life cycle? We are at 25 years, probably for the facades, starting to speaking about the major repair circle. We are probably going to advise our client possibly to prolong the life with the repair, possibly 5-10 years. Or we may speak about adapt or conserve this building. Demolishing at this current environment, at least in London, is probably last and least option, which probably nobody is going to go into at the moment. There are quite restricted conditions when you can demolish something. So, design options, what we can do. And I will probably explain this better on the project examples. But it is also depending on if the project is listed, if there is any heritage on this building. If it is, then we are really speaking about like-for-like replacements with full retention, and maybe we can address a very small item, minor items, or address some of the problems with the building. If it is not listed, or if we can get beyond the point of we can do some improvements, we can do a partial performance upgrades with the retention of original structures, or we can go with full upgrade. But again, we're still thinking about at least partially retain some of the original components. If it is in the client's interest and architectural interest to build something new in the existing building, that's also an option. So what are the challenges with working with the old buildings? I think it is usually the project documentation, to understanding what do we dealing with and how this is working. Usually there are quite difficult discussions about the condition assessment and surveys which needs to be done to address is it performing and behaving as it's supposed to be. And there is also a little bit discussion about the reliability. We'll not go into any depth of it, but you will probably understand why this is a discussion. So, past project documentation. It's always fun to dig up the old boxes if you have them, and if you have them, you are very lucky, because most of the time you don't have them, and then what do you do? So, I think in Europe we have a lot of these boxes somewhere. I don't know where they are, but there is every project does have a couple of them. And one time I came to the office and there was a lot of boxes, and I said, anyway. So if we have a project documentation, that's perfect. I think again in Europe back in the days they microfilmed a lot of those projects in the digital form. So it's very good and very useful for everyone involved in the process to work with it. And there are also in those boxes a lot of faxes and like today we're sending emails, they send the faxes and letters, and sometimes it's quite fun to read them. Not all of them can be disclosed. And also all of the calculations, which kind of like handwritten, nicely explained, something what we always ask contractors to do, never get it, and engineers obviously. But I think you can see that it is the load paths are explained, and the theory behind how did you do it is clear. But let's imagine that we're building something new. How we are getting over this problem of scattered information over a couple of the resources, sourcing from clients, engineers, architect office. Can we manage better? Can we, if we get ourselves into mindset of next generation or older version of Peter in 30 years, coming and calling the client or architect, saying you have this project which you built 30 years ago and now needs your help. How would you remember and how would you go through your information? And I think building the dashboards and data sets is really, really useful to have something which is clear and clearly labeled. So the condition assessment is very important because you can get some information from the drawings and calculations, but I think how the structure aged is important. And I think it was triggered really by the pandemic. It's one of the good things of the pandemic, probably, is that we needed to very quickly deploy new technologies. And we used that company, which is examining oil rigs in the North Sea. And obviously, those are the very dangerous places where people cannot just really work easily. And they used the drones long before pandemic to look into specific of those and created these super duper BIM models and digital twins from that. And I think they really expanded into the architectural or into building business in the pandemic because it was basically their information ready. They could do it for really easy money. And then I think you can build your databases. You have all the information at your hand remotely. You don't need to be at the site present. And you can do whatever you need to do to assess the condition of the building. And then, obviously, if you have these recordings, you can also look into and create your own dashboards to log all the information of each of the components on the dashboard, so you know and you present your clients accordingly. So the thing is that working with the old buildings and refurbishing all the buildings, it's not the cheapest way of doing things. It's quite expensive. You need to dig a lot of information. And if you need to strengthen some of the components or add some of the components, it's quite difficult because you need to work with existing fabric, which is not that easy. So I will go here and just very briefly, the reliability assessment of the new is clear and easy. There are codes, but there are also codes for existing buildings. And those codes and the safety factors and the reliability factors are much lower than for the new buildings. Of course, if you can work with the current safety factors and codes, no problem. But usually with the existing buildings, you will be struggling because the codes were different and the different safety approaches were applied. As well as, I think, unfortunately with the glass, because for the past 50 years, we've been designing glass not according to the code, but according to some rules which were not always written clearly. It's not really it's quite difficult to justify something according to the latest codes or according even the existing building codes. So I will speak about the project examples, a couple of them. And it really started with Lloyd's. It was kind of like a pioneering project, and then went down to others. And now I think we can see more and more of it. So I think I will probably, this is the best explaining picture, and this is why I choose to speak about those projects and those topics, is because this is the way of growth. You can see the clear growth of how many projects, existing projects we had in the office, and where we are going probably with it. So the first one is the engineering building in Leicester, 1963, Stirling building. Lovely building from outside. Listed 2 building, a lot of prices and architectural merit. However, client was at the edge of demolishing it. It was difficult to maintain. It was obviously leaking all over the place. It's very nice. It was always hot or cold. It was single glass. It's kind of the institutional building from 1960s, exactly what you would expect, and probably where we all go to school, to university or somewhere, where we had these problems with it. It was listed, so it couldn't be demolished, so we needed to do something. And the Heritage came up with, so that was the existing one. Heritage came up with some idea of what from the Heritage perspective, what they want us to do, what are the limits, zones we can go into, and then we need to come up with the design which closely enough represented the heritage value of the project. So at this project, we replaced the single laminated glass with DGUs and new glazing frames. We kept the steel structure, then do a lot of testing. Obviously, all these components and 3D junctions, as you can see, it's quite complex and difficult, so it was quite a lot of fun. The next one is the Borough Collection in Glasgow, 1983. Again, timber structure, timber mullions, listed building. What we done here, we again deglazed it. We kept the glazing bar, existing glazing bar, and changed the gasket and changed the unit only. And Graham will be speaking about this. We reused put the glass into recycled. The next one, which I cannot speak much about, but Channel 4 headquarters. I think Peter Rice and RFR design, super special. All the glass panels are hung from each other, no dead load support. All the glazing is single glass, 12mm thick, not laminated only at the bottom for the impact. So in the case one glass panel failed, there was some strategy to deal with the load distribution, but quite tricky. So getting the good understanding of how this actually works, how this performs in the original state, examining, testing all the components, looking into how the clamps and connections aged, and hopefully we will be more speaking about this in the next couple weeks, months, years. Another project, Norman Foster, 78, Sainsbury Centre, 8-meter tall glass fins, annealed, not laminated, spanning a distance, silicon glued with exactly 7.5 millimeters of a transparent transparent sealant, not structural. Yeah, so I think again, how are you going and justify that this is actually fine? It is fine because it is there, but if you need to write your signature that it is fine and it can be there for another 10, 15, 20, whatever, X years, then how do you do that? And we asked industry, by the way, can you supply to us a transparent structural silicon? And somehow nobody responded. Why? Because it doesn't exist. So how we are going to deal with it? Because everyone loves this. This is a close-up of the film. This is what historic England and all the people wants to see, Fosters want to see. This is why the building is so important, because the light is shining through the glazing, through the fin, and you see these nice green lights. And other aspect of this one is it is a 19mm thick glass fins, and telling you they really have balls. They really designed it, and they designed it to safety factor of 1.1. And otherwise, then it will buckle. So I think it is really, if you think about the sustainability and the designing to the limits, it is what it is. What we are going to do when one of the panel fin is breaking or break, how the load will reshare and redistribute, it's a different topic. So I think concluding this one is the condition assessments are important. I think doing the proper project research and desktop studies to get to the bottom of what was the structural and architectural intent of the building, understanding the client's brief. clients may have a different expectation and expenditure, let's say, and they really sometimes want to demolish it and sometimes want to just retain it for over 5 years. So it is this really holistic approach to design. What can you do and work with them? And then I think at the end of the day, what the industry is happy to do, because warranties and discussion with the contractors, they will not do everything which they happily did 35 years ago. There is still 20% of the new build projects which we have time to build. So how we do the engineering the present to build sustainable future. We can do some playfulness and experimentation, pushing the engineering boundaries again, not over-designing anything. Understanding the materials and codes and everything is important. Stress screens and material optimization, advanced engineering and materials, modular design, and effortless disassemble. I think that's what we learned from the project which we are working on. You need to think about what will happen in 20, 30, 40 years when someone will be in your shoes and trying to do something with those new projects. And then I think so full recyclability and reuse. And I'm minus 40 seconds, so thank you very much.